Hi everybody. We've kind of been jumping around a little bit. We're going back to lesson 4 and we're going to talk about scientific notation today. In this lesson, you'll be able to express large and small numbers using scientific notation. Okay, so what is scientific notation? Well, it's a method that somebody came up with that's used to write very small or very large numbers as a product of a number and a power of 10. And you'll see what I mean in a bit, but rather than write 564 billion or trillion or kajillion, they came up with this other way of writing it so that it is still equal to the same value, but it's easier for the person to write. Standard notation is different than scientific. Standard notation is just the number as we normally write it. For example, 48. 48 is in standard notation. That's just the way we write it, okay? And scientific notation, it would look different, and you're going to see that in a second. So let's use what we know about the power of 10 to help us with scientific notation. So when we do powers of 10, we count how many zeros are in the number, and that's the power we're going to do. So 1, 2, 3, 4, 5. There are 5 zeros, so I am going to say 10 to the 5th power. Here I have 4 zeros, so 10 to the 4th power. 3 zeros, you get the idea. So I'll finish this up here. And remember that 1 is 10 to the 0 power. Okay, because there are no zeros, but there's still a 1. Okay, and it's the ones place. And remember also when we have 0.1 or 1/10, 1/10 is 10 to the negative 1. And 1/100th is 10 to the negative 2. And remember, negative exponents mean to change position. So this puts the 100 down in the basement in the denominator and lessens its value. It's not worth much at all. And this would be 10 to the negative 3, which is 1/1000th. 1/1000th. And then 1/10,000th would be 10 to the negative 4. So, just a quick reminder, look at these and ask yourself, what do positive exponents represent? And what would you think they represent? Big or small numbers? They represent big numbers, so they represent large numbers, okay? Big numbers. Numbers bigger than 1. And what do negative exponents represent? I would say they represent small numbers. Okay? Because these are all decimals here. Okay, we're going to look at some examples of scientific notation and non-examples. This is a good strategy to help your brain and see what is scientific notation, what isn't, and then you can figure out what the rules are. So here we have 3.85 times 10 to the 5th. Now here we have 8.43 times a 5 to the 8th. Let's look at this one. We have a number, 1.002 times 10 to the 4th. Here, we just have a number. We don't have any times sign. So, feel free to pause and just look at the differences. And what I want to point out is, in scientific notation, all of these have numbers right on the left. And notice they all have a decimal right after the first number. So that means they're all in the ones place, okay? They're all less than 10. And they also have something else in common. Look at this. They all have a multiplication sign. They also all have a 10 with an exponent. So knowing that, try and point out what's wrong with some of these non-examples. Here, we do have a time sign and a 10 and a 12, but look at this number is 45. It's bigger than 10, okay? And this number is, whoa, way smaller. It does not have a number in the ones place. This has a number in the tens place. We want the ones place only. So this one doesn't work. Same thing here, okay? So let's write the rules for scientific notation. The first rule, and please write it down on your sheet, is that you must have a number that is greater than or equal to 1, the number, and it has to be less than 10. So let's see. Is 3.85 greater than 1 but less than 10? Yes. All of these work. All of these fit in this category. So that's the first rule. The second rule is you must have a time sign. It is a multiplication problem. It is a product. Times, 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 times. Good. We have it. Lastly, you must have a 10 with an exponent. So let's look. 10, exponent, 10, exponent, 10. Now we have a negative exponent, but we'll talk about that later, but it's still an exponent. 10, exponent, 10, exponent. Awesome. So these are the three things you must have to be in scientific notation.